Hey everyone, and welcome back to the channel. Get ready for another exciting episode where we break down some of the most groundbreaking AI research papers of the week. We'll be exploring innovations in video depth estimation, personalized image generation, dynamic human animation, 3D asset generation, point tracking, and much more. If you're passionate about AI, you're in the right place. Join us as we go step by step into these cutting-edge technologies and see how they're shaping the future. Let's jump right in. Paper number 1, Hunyuan 3D 2.0, High-Resolution 3D Assets Generation with Large-Scale Hunyuan 3D Diffusion Models. Today, we're diving into a fascinating paper titled, High-Resolution 3D Assets Generation with Large-Scale Hunyuan 3D Diffusion Models. This research from the Tencent Hunyuan 3D team introduces Hunyuan 3D 2.0, a powerful system for creating high-quality 3D models. What makes this paper unique? Well, it's not just about generating any 3D model, it's about creating high-resolution, textured 3D assets with impressive detail. Hunyuan 3D 2.0 uses a two-stage process. First, it generates the basic shape or mesh using a large-scale shape generation model called Hunyuan 3D DIT, which is based on a flow-based diffusion transformer. This model is designed to align the geometry with a given condition image. Think of it as the skeleton of your 3D model. Then, it uses Hunyuan 3D Paint, a large-scale texture synthesis model. This model adds high-resolution, vibrant textures to the mesh, using both geometric and diffusion data. This two-stage process is really effective and helps with the complexities of shape and texture generation, which provides a lot of flexibility for texturing either generated or handcrafted meshes. The researchers didn't just stop there, they also developed Hunyuan 3D Studio, a user-friendly platform that simplifies the process of creating and manipulating 3D assets. It lets both professionals and beginners work with their models. In their testing, Hunyuan 3D 2.0 outperformed other open-source and closed-source models in terms of geometry details, condition alignment, and texture quality. This paper provides a significant step forward in making high-quality 3D asset creation accessible to everyone. It's exciting to see where this technology will take us. Paper number 2, DiffVSR, Enhancing Real-World Video Super Resolution with Diffusion Models. We're exploring a cutting-edge paper called DiffVSR, Enhancing Real-World Video Super Resolution with Diffusion Models for Advanced Visual Quality and Temporal Consistency. This research introduces DiffVSR, a novel diffusion-based framework designed to tackle the challenges of real-world video super resolution. What makes this paper unique is its ability to achieve high fidelity and maintain temporal consistency in upscaled videos, addressing issues that other methods often struggle with. DiffVSR incorporates several key innovations to achieve its results. For inter-sequence coherence, which means making sure the video looks consistent within a scene, the researchers developed a multi-scale temporal attention module and a temporal enhanced VAE decoder. These components help capture detailed motion and ensure spatial accuracy, so the upscaled frames accurately represent the motion in the low-resolution video. For inter-sequence stability, which means making sure the video looks stable across different scenes or shots, the team uses a noise rescheduling mechanism combined with an interweaved latent transition approach. This approach works to create smoother, more consistent video, without adding training complexity. To effectively train DiffVSR, the researchers designed a progressive learning strategy that transitions from simple to complex degradations. This enables the model to handle various real-world video degradation scenarios effectively and be robust, even with limited high-quality video data. The paper highlights that DiffVSR surpasses existing state-of-the-art video super resolution methods in both visual quality and temporal consistency. In conclusion, DiffVSR sets a new benchmark for real-world video super resolution and opens the door for high-quality video restoration in many practical applications. Paper number 3, Textoon, Generating Vivid 2D Cartoon Characters from Text Descriptions. We're diving into another fascinating paper titled, Textoon, Generating Vivid 2D Cartoon Characters from Text Descriptions. This paper introduces Textoon, a new method for generating diverse 2D cartoon characters in the live 2D format using text descriptions. What makes Textoon unique is its ability to create interactive 2D characters that simulate 3D movement without needing a complete 3D model. It is also able to generate these characters in about a minute. This is a big step forward in making 2D character creation both accessible and efficient. Textoon uses a framework that starts by parsing text to extract detailed descriptions of character components. This includes features like hairstyle, eye color, clothing, and more. Then, it synthesizes these components into a comprehensive character template, defining the character's shape and appearance. A text-to-image model is used to generate the inner color and texture. Textoon also allows users to edit details if they are not happy with the generated results. This means they can add, remove, or modify different elements. Furthermore, Textoon also addresses the challenge of animation. It uses Arkit's face blend shape capabilities to improve the realism of lip-sync animations for the generated characters. This feature enhances the accuracy of speech animations. The system is capable of generating diverse 2D characters with the ability to create a wide range of looks based on textual prompts. Textoon supports both English and Chinese prompts. In conclusion, Textoon offers a powerful tool for generating interactive 2D characters that can be used in various applications. Paper number 4, GSTAR. Gaussian Surface Tracking and Reconstruction. We're exploring a fascinating paper titled GSTAR, Gaussian Surface Tracking and Reconstruction. This paper introduces GSTAR, a novel method for achieving photorealistic rendering, accurate surface reconstruction, and reliable 3D tracking for dynamic scenes with changing topology. What makes GSTAR unique is its ability to handle complex topology changes, such as surfaces appearing, disappearing, or splitting, which is a significant challenge for other tracking methods. X-Dyna works by binding Gaussians to mesh faces to represent dynamic objects. For surfaces with consistent topology, GSTAR maintains the mesh topology and tracks the meshes using Gaussians. When topology changes occur, GSTAR adaptively unbinds Gaussians from the mesh, allowing for accurate registration and the generation of new surfaces based on these optimized Gaussians. This allows the system to track dynamic surfaces frame by frame. X-Dyna detects these changes based on positional gradients and reconstruction errors. It then generates new faces for new geometry and connects them to the original faces. The system uses a scene flow method to provide robust initialization for tracking between frames. This helps the system to accurately warp the previous frame's results. X-Dyna reconstructs Gaussian surfaces by fixed topology reconstruction, adds new Gaussians as needed to handle topology changing surfaces, and updates the Gaussian surfaces through remeshing. The researchers plan to release their implementation to facilitate future research. In summary, GSTAR provides a robust approach to tracking and reconstructing dynamic surfaces, opening up possibilities for a variety of applications. Paper number 5, A3 Syn, Towards Affordance-Aware Articulation Synthesis for Rigged Objects. We're diving into an innovative paper titled Towards Affordance-Aware Articulation Synthesis for Rigged Objects. This paper introduces A3 Syn, a novel method for synthesizing realistic articulations for rigged 3D objects, taking into account their affordances within a given scene and context. What makes A3 Syn unique is its ability to generate context-aware poses for arbitrary, open-domain rigged objects, without relying on extensive training data or making assumptions about the rig structure. This means the system can handle a wide variety of objects and scenes, adapting their poses to fit the environment, the laws of physics, and even the object's personality. A3 Syn works by taking 4 inputs: the scene geometry, the rigged object, a text prompt describing the desired posture, and an approximate location for the pose. It first synthesizes a rough proposal posture and then refines it through a 2-stage optimization process. The first stage focuses on single-view pixel alignment, while the second stage uses a combination of a grid prior and partial denoising to achieve cross-view consistency. This multi-view approach is crucial for resolving depth ambiguities and ensuring the final pose is realistic. This allows the algorithm to synthesize a final pose that is both physically plausible and semantically appropriate to the given context. The system has stable convergence, completes in minutes, and can synthesize plausible affordances for various objects in different scenes. The paper demonstrates how A3 Syn can adapt a variety of objects, such as animals, to different environments, showcasing how a rabbit's jumping posture differs from a cat's or dog's, and also how the same object adapts to various scene geometries. The method is also shown to produce more natural poses compared to other methods, such as SDS, which can lead to unnatural limb distortions. Paper number 6, Chrono, Exploring Temporally Aware Features for Point Tracking. We're diving into a fascinating paper titled exploring temporally aware features for point tracking. This paper introduces Chrono, a novel feature backbone specifically designed for point tracking with built-in temporal awareness. What makes Chrono unique is its ability to capture long-term temporal context, enabling precise prediction without the need for a refinement stage, which is a common but computationally expensive practice in other point tracking methods. Chrono leverages the power of pre-trained representations from self-supervised learner, DINOv2, to handle real-world data effectively. However, DINOv2 alone lacks motion awareness, so Chrono enhances it with a lightweight temporal adapter. This adapter is placed between each transformer block of DINOv2. It reduces the spatial resolution of extracted features, performs local window temporal attention to capture point movements, and then restores the features to their original dimensions. A residual connection preserves essential details from the original feature map. This spatiotemporal approach allows the architecture to learn the cues necessary for accurate point tracking across challenging video sequences. The quality of features extracted from Chrono is measured by tracking points purely through feature matching using cosine similarity. A soft argmax operation pinpoints the most likely location based on correlation scores. Chrono demonstrates exceptional performance and position accuracy compared to other backbones, proving its ability to effectively model spatial and temporal information. Furthermore, PCA analysis shows that features from Chrono exhibit greater temporal smoothness across consecutive frames compared to DINOv2, leading to more continuous trajectories and reduced abrupt changes. The model also shows better smoothness and precision than other competitors in real-world video tracking. Paper number 7, X-Dyna, Expressive Dynamic Human Image Animation. We're diving into a really exciting paper titled X-Dyna, Expressive Dynamic Human Image Animation. This paper introduces X-Dyna, a novel, zero-shot, diffusion-based pipeline for animating a single human image using facial expressions and body movements derived from a driving video. What makes X-Dyna unique is its ability to generate realistic, context-aware dynamics for both the subject and the surrounding environment. Unlike previous methods that focus on human pose control, X-Dyna enhances the lifelike quality of human video animations by addressing key factors that lead to the loss of dynamic details. At the core of X-Dyna is the Dynamics Adapter, a lightweight module that integrates reference appearance context into the spatial attentions of the diffusion backbone. This ensures the model can synthesize fluid and intricate dynamic details while preserving motion module capabilities. In addition to body pose control, X-Dyna uses a local control module to capture identity disentangled facial expressions. This allows for accurate expression transfer, making animated scenes more realistic. The method is a unified framework capable of learning physical human motion and natural scene dynamics from a variety of human and scene videos. The X-Dyna model is trained to synthesize animations without any post-processing. The results from the model show that X-Dyna outperforms state-of-the-art methods, creating highly lifelike and expressive animations. The model achieves remarkable transfer of body poses and facial expressions, as well as highly vivid and detailed dynamics for both the human and the scene. The researchers also provide a BibTeX entry for citing the paper. They also acknowledge the support of a few researchers who provided helpful suggestions. Paper number 8, TokenVerse, Versatile Multi-Concept Personalization in Token Modulation Space. This paper introduces TokenVerse, a method for multi-concept personalization using pre-trained text-to-image diffusion models. What sets TokenVerse apart is its ability to disentangle complex visual elements and attributes from as little as a single image. It also enables seamless plug-and-play generation of combinations of concepts extracted from multiple images, going beyond the limitations of existing methods. TokenVerse leverages the modulation mechanism within DT-based text-to-image models, observing that the modulation space is semantic and enables localized control over complex concepts. The method focuses on the modulation block of the DIP model, where tokens are modulated via a vector derived from a pooled text embedding. The core of TokenVerse involves learning a personalized modulation vector adjustment, delta, for each text embedding based on a concept image and its corresponding caption. These adjustments, representing personalized directions in the modulation space, are learned through a simple reconstruction objective. At inference, these pre-learned direction vectors are added to the text embeddings, thus injecting the personalized concepts into the generated images. TokenVerse can handle a wide range of concepts, including objects, accessories, materials, pose, and lighting. This includes abstract concepts like lighting, posing, and texture. This technology enables interesting possibilities such as storytelling, where one can generate a narrative consisting of images featuring the same objects and scenes. The effectiveness of TokenVerse is showcased through its capabilities in challenging personalization settings, demonstrating its advantages over other methods. Paper number 9, AnyStory, towards unified single and multiple subject personalization in text-to-image generation. This paper introduces AnyStory, a unified approach for generating personalized images, focusing on both single and multiple subjects. What makes AnyStory unique is its ability to achieve high-fidelity personalization without sacrificing subject detail. Whether you're generating an image with one specific subject or several, it addresses a key challenge in text-to-image generation, maintaining the accuracy and detail of personalized subjects. AnyStory follows an encode-then-route paradigm. First, it encodes the subject using a reference net, combined with a clip vision encoder, to capture subject features with high fidelity. This encoder creates a detailed representation of the subject. Then, a decoupled instance-aware subject router is used to guide the injection of subject conditions. This router perceives and predicts the location of the corresponding subject in the latent space, which allows for accurate placement of the subjects in the generated image. This routing mechanism allows AnyStory to handle multiple subjects without losing fidelity. The training process is divided into two stages: the subject encoder training and the router training. The method is designed to retain subject details, align text descriptions, and personalize for multiple subjects effectively. All subject images referenced in the paper are sourced from Pixabay and Unsplash. The researchers also provide a BibTeX entry for citing the paper. Paper number 10, Video Depth Anything, Consistent Depth Estimation for Super Long Videos. We're diving into a new and very interesting paper titled Video Depth Anything, Consistent Depth Estimation for Super Long Videos. This paper introduces Video Depth Anything, a method that builds upon Depth Anything v2, to estimate depth in videos of any length. What makes this paper unique is its ability to provide consistent, high-quality depth estimation across entire video sequences, even very long ones, with good generalization ability. Video Depth Anything leverages the power of Depth Anything v2 and addresses the challenge of maintaining temporal consistency in depth estimation across video frames. The method starts by using the first frame of the video to establish the camera's intrinsic parameters and to find aligned scale and shift parameters. This is achieved by running the first frame through MOGO, a powerful model for recovering 3D geometry from monocular open-domain images. MOGO helps set the foundation for consistent depth estimation throughout the entire video. By doing this, Video Depth Anything can produce accurate and stable depth maps for each frame of a video. The paper includes comparisons with DepthCrafter on both open-world videos and unprojected point clouds, highlighting the superior performance of Video Depth Anything in delivering temporal consistency. The researchers have also made the code available, along with a Hugging Face demo, so you can check it out for yourself. If you're interested in learning more about the technical details, make sure to look up the citation and explore the resources provided. And that wraps up our deep dive into this week's top AI research papers. We hope you found this breakdown insightful. If you enjoyed this video, make sure to like, subscribe, and hit that notification bell so you don't miss out on future tech explorations. Let us know in the comments below which paper you found most fascinating. Thanks for watching, and we'll see you in the next.